Hello my dear students, how are you? I hope all of you are fine and staying at home safely. This is your teacher Nasim Ahmed from Ideal Public School Katigoda. Students, I am here for class 9 science and today I'll be discussing this second chapter, Is Matter Around Us Pure? So students, we already have completed the first chapter and we know the concept of matter. Okay? So if you have this question in your mind that is matter around us pure, means everything around us pure, so you watch this video till the end. I hope you will get your answer. And this chapter actually I have divided into 4 parts. So this is the first part you are watching and the rest of the parts will be coming soon. Stay tuned for that. So without any further ado, let's get started. Students, so as you can see, these are the topics that we'll be covering in this video. So firstly we'll understand about what is substance, then what are pure substance, then we'll understand about what is mixture and types of mixtures, and solution, alloys, then we'll understand about properties of a solution and stable solution, different types of solution, and lastly we'll understand about concentration. So let's jump into the first question that you have. Students, the first question that is in front of us is, what is a substance? What is a substance? Let's read out the definition. A substance is a pure single form of matter. Pure single form of matter. It cannot be separated into other kinds of matter by any physical process. As for example, salt, sugar, water, diamond, etc. So let's understand this. So what is substance? Substance is basically matter. Okay, substance is basically a matter that is pure single, means that is in pure single form. So if I talk about salt, if I take the example of salt, I'll say inside the salt you will have the particles of salt only. You will not find the particles of sugar, you will not find the particles of water or diamond, okay, or any other kind of particles inside this salt. That means this salt, okay, this salt is a pure single form of matter. It has only the particles of salt. This is what? This is a substance. This is a substance. If I take the example of sugar, then inside the sugar the particles of sugar will be present. It will not consist of the particles of salt or water or diamond or any other particle. That means this is also what? A pure single form of matter. And you see, it cannot be separated into other kinds of matter. So you will not find other kind of matter. So how can you separate them? How can you separate them physically? You can do it chemically, this is another stuff, but physically this is not possible. Okay, so by this way you can understand the definition that a substance is a pure single form of matter. This is very important line. It cannot be separated into other kinds of matter by any physical process. So nextly you have matter can be classified into 2 types of substances, pure substance and mixtures. Okay, so all the matters that is around us, can be separated into 2 types of substance. One is pure substance, one is impure substance. Pure substance is what? That we have just understood, like sugar, water, diamond, salt, all are what? All are pure substance. But if you talk about impure substance, maximum of the substances are impure. We'll see, we'll find it later on this chapter, that all means maximum of the substances, maximum of the matters are what? Impure substances. Like they are not present in pure form. They have some other substances included and forming a different kind of we can say matter or different kind of substance. Okay, next question, what is a pure substance? So you have this definition of pure substance. A substance that consists of only one type of particle is called a pure substance. So what is pure substance? The substance which is consist of only one type of particle. You see, this is a very important term. Only one type of particle is called pure substance. So as I have given the explanation earlier, in diamond you will find the particles of diamond, you will not find the particles of salt. This is what? Pure substance. Okay, pure substance. Then you have salt. Salt is also composed of what? Only the particles of salt. Then you have sulfur. This is the picture of sulfur. This is the picture of tin. Okay, so all these are what? All these are composed of their respective particles. Okay, that means you will find only one type of particle inside each of the stuff that I am showing here. Okay, then you have what is mixture? What is mixture? So if I talk about mixture, this is pretty much interesting. You see, when we combine different substances into each other, a mixture is formed. This is very important. You can see whenever you are combining two or more substances into one form, this is what? Mixture. This is what? Mixture. For example, you can take lemonade. This is lemonade. You can see here is a mixture of three substances: lemon juice, sugar and water. This one though I like very much. I don't know about you. I know you also like it. In these summer days we like to have this one. Okay, so lemonade is what? A mixture of three substances. So inside this lemonade you have three substances. One is lemon juice, the juice of lemon, then you have sugar, and then you have water. So we can say this is what? This is a mixture. You have three substances. One is lemon juice, then you have sugar and water. These three are combined in one form. By this way this lemonade is formed, isn't it? So this is what? A mixture. So I hope the concept of pure substances mixture is clear to you. Pure substance is where only one kind of particle is there, no other kind of particle would be present in pure substance. But in case of mixtures, you will find two or more than two types of particles present. Okay, so here comes the question, which of these is a mixture or a pure substance? So let's find it out. You have some of the examples here. You have water, you have copper, chocolate cake, hydrogen, soil and air. So firstly you will see water. Inside water, do you think you will find any other kind of particle present? I don't think so. Water is having the particles of water present, that's why it is a pure substance. As you can see here, water is written under pure substance. Then you have copper. Copper is also what? Means in what purpose copper is used? Copper is used for basically electrical wiring. Okay, this is a good conductor of electricity. So as you can see in the picture here, coppers are used as coppers are basically pure substance. Okay, then you have hydrogen also. Hydrogen also what? If I say about hydrogen gas, then this hydrogen gas would be containing the particles of hydrogen. No other kind of gas would be present there. So this is also what? This is also a pure substance. But if I talk about chocolate cake, you know this chocolate cake can means for the preparation of chocolate cake you need different substances like flour, you need chocolate, you need sugar, you need different other substances. That means this chocolate cake is not a pure substance. It has so many other particles present inside. That's why it is a mixture. Okay, chocolate cake. Then soils are also composed of different substances, not a single substance. That's why it is a mixture. Then you have air. We know if I take a section of air like a box, inside a box the air present would be like different kind of gases present on it. So we cannot say like air is a pure substance. It is a mixture of different gases. That's why air is a mixture. Okay, I hope this concept is clear to you. Let's jump into the next topic that we have. Students, now we have come up to types of mixtures. Now you listen very carefully because these concepts are very important for you. So while understanding the types of mixture, there are two categories of mixtures. One is homogeneous mixture and another one is heterogeneous mixtures. So mixtures are basically categorized into two types. One is homogeneous mixture and another one is heterogeneous mixture. So what is homogeneous and what is heterogeneous, we'll understand it now. So homogeneous mixture, let's understand homogeneous mixture first. Okay, so you have when we add sugar, okay, sugar, water and lemon, sugar, water and lemon juice together, they all uniformly mix with each other. Now it is not possible to separate these substances from the mixture. Such mixture in which the components mix with each other uniformly are called homogeneous. Very nicely explained here. If you read this paragraph, you can definitely understand what is homogeneous mixture. Students, you can understand this from this diagram here. You have this diagram. Inside this box you will find some balls. Some balls are green colored and some balls are purple colored. Okay, so you can see here, first in the first row you have two purple colored ball and two green colored ball. In the next row you have two purple colored ball and two green colored ball, isn't it? In the next row also you will find the similar you can say ratio. Okay, so that means these particles, if I consider these as particles, then you can say these particles are uniformly distributed and there is less possibility that you can separate them out because they are uniformly distributed and they are, you can say, very much closely attached with each other. Okay, they have a configuration, we can say they have a configuration by which they are attached with each other. So here the example was when we add sugar, water and lemon juice together, then the three particles, they uniformly mix with each other and you cannot separate them, okay, from one another. So after adding them togetherly, you cannot separate them. So this is what homogeneous mixture. So we can say homogeneous mixture is a kind of mixture where the particles are uniformly distributed, okay, or we can say uniformly mixed, and the particles are means the particles cannot be separated from each other, we can say like this. Okay, then the ratio of components of homogeneous mixtures can be different. Okay, for example, one may add 2 spoons of sugar in lemonade, while someone else may add only 1 spoon of sugar in their lemonade. Still lemonade is a homogeneous mixture. So if I say like while forming this solution with sugar, water and lemon juice, that would be called as lemonade. If I talk about this, and if I say like one person is adding 1 spoon of sugar and another person is adding 2 spoons of sugar, then their means composition is different, so this is heterogeneous. No, this will not happen here, because you have, if you add 1 spoon of sugar or 2 spoon of sugar, 2 spoon of sugar, they uniformly combine with the solution and they will form the solution, and the particles of the solution would be uniformly distributed. That's why it would be called as homogeneous mixture. Okay, I hope you have understood this one. Let's talk about heterogeneous mixture. Heterogeneous mixture, the components in a heterogeneous mixture do not completely dissolve in each other and we can separate them by physical means. So this is very important. We can separate them by physical means. In other words, the composition of such mixtures is not uniform. So here we have seen in homogeneous mixtures that the particles of the homogeneous mixtures are uniformly distributed and they cannot be separated from each other. So heterogeneous mixtures are opposite of homogeneous mixtures. Okay, so the components can be uniformly, they are not uniformly distributed, that's why they can be separated by physical means. This is very important. Physically you can separate them. For example, if you mix sand in water, the sand settles down in water after some time, and we can separate it by filtration. So this is very easy example you have. So here from this diagram, how you can understand, so this is what mixture, it is divided into heterogeneous and homogeneous. So we have already understood about homogeneous mixture. So here you have heterogeneous mixture. These are the purple colored ball and these are green colored ball here. So you see these are randomly placed. Okay, there is no composition, there is no we can say symmetry of the composition of the balls. Okay, so these purple colored balls are above and these we can say green colored balls are down, so we can separate them easily by any means. Okay, so here the example is taken for sand and water. If you mix sand in water and after sometimes you will find that the sand will be settled down, then you can separate them easily by filtration. Okay, so now let's talk about the differences between homogeneous and heterogeneous mixtures. So firstly, homogeneous mixtures, they have a uniform composition throughout. So this thing we have already understood about it, uniform composition, and it has non-uniform composition. In case of homogeneous mixture, we cannot separate the components of the mixtures through physical process. So we cannot separate them, but here in heterogeneous mixture we can separate them by physical process. Okay? This is very important. Components cannot be seen through naked eyes. So after dissolving the sugar or after dissolving salt, you will find the solution of water would be what? Would be transparent, like the earlier one, clear one. Okay, very clear. But in case of heterogeneous mixture, the solution that will make with that is heterogeneous mixture would not be clear. Okay, would not be clear, and the components can be seen through naked eyes. Then the mixture is in single phase throughout, and this one, the substance can be of two different phases, and we may see separate layers of the substance. So suppose like if you add salt in water, then you will find there is no difference in the particles. Okay, there is no difference, there is no layer present in it, it's a single solution, you will find it. But if you add, suppose like oil on water, basically simply oil on water, then you will find that two layers of particles are there. In the upper side you may find one particle, that is we will find oil, and in the lower layer you will find water. So you will find two different phase or two different layers. Okay, then for example, you have a mixture of water and milk, then here you have mixture of oil in water. So I hope you have understood this concept of homogeneous and heterogeneous. So let's remind it again. Homogeneous mixture is what? Is a mixture where the particles are uniformly distributed and they cannot be separated from each other. In case of heterogeneous mixture, the particles are non-uniformly distributed and the particles can be separated by physical process. Okay, so here this topic ends. Let's see the next one, students. Now the next very important question is, what is a solution? What is a solution? So we have understood about mixtures where two or more than two substances are present, and here you have homogeneous and heterogeneous mixtures. We have already understood about homogeneous and heterogeneous mixtures. So under homogeneous mixture you will find solution. Okay, you will find solution. Under heterogeneous you will find suspension and colloid, or we can say colloidal solution. We'll understand this later in the later parts of this chapter. So in this chapter we'll understand about solution. So let's understand what is solution. So you see, a solution is nothing but a uniform mixture of two or more substances. So it's a mixture, that means more than two or two substances are present here, but they are uniform. Okay, they are uniform. Homogeneous mixtures are solutions. Homogeneous mixtures are solutions. So we have understood about homogeneous mixtures where the substances cannot be separated from each other, and the substances the particles of the substances are uniformly placed. Okay, so if the particles are uniformly placed, then it is a solution. Basically, it's a solution. So for example, we can say solution of liquid into liquid in case of water and ink. This is what, when we mix water in ink, then we find a solution where liquid and liquid solution where water and ink is present. Solid into solid, these are alloys. We'll understand it. What are alloys? You can see the question here. What is an alloy? We'll understand it later. Here you have solid into solid. When liquid is mixed in liquid, then it is what? A kind of solution. Okay, and the particles are uniformly placed, then it's a solution, and it is liquid into liquid solution. Then you have solid into solid solution where you have solid particles mixed with another kind of solid particle, and the particles are uniformly placed. This is what? Alloy. This is an example of solid into solid solution. Then you have gas into gas. This is air, we know it already. Then you have solid into liquid, sugar and water. If you make one sugar solution, then you will have water as a liquid, and the sugars that are solid particles are added in the water, and they form a solution. Then you have solid into gas, hydrogen and metals. Then you have liquid into gas, carbon dioxide and water. So these are some examples of solutions where you will find liquid into liquid, solid into solid, gas into gas, solid into liquid, solid into gas, liquid into gas. I hope you have understood about solution. The concept of solution is very much important for you, as you have so many things going on in this chapter regarding solution. So you need to understand this, that solution is what? Basically a homogeneous mixture where the substances are uniformly placed, or we can say the particles are uniformly placed, and this is what? This is a uniform mixture basically. Okay, we can say in one word that uniform mixtures are called solutions. Okay, uniform mixtures of two or more substances. So basically mixtures are what? The composition of two or more substances. So in one word you can say uniform mixtures are called solutions basically. Okay, so let's understand the next question. This is, what is an alloy? What is an alloy? So here you have, an alloy is a mixture of different metals or non-metals and metals that cannot be separated from each other using physical methods. So we know about it, that in case of solution you cannot separate them. So for alloys are what? Solid into solid solution. So alloy is a mixture of different metals or non-metals. You can say non-metals. We know about metals and non-metals already, and they cannot be separated from each other by physical process. For example, brass. This is a very important example. When copper with up to 50% zinc. In copper, zinc is added up to 50%. This is brass. And we know about bronze. So bronze is what? When inside copper 12% of tin is present, this is called as bronze. So these are what? Basically these are alloys. So we know about bronze because whenever in a competition someone gets the third prize, they get what? Bronze medal, isn't it? We know about first prize is gold, second prize is silver, third prize is bronze. So bronze is what? Is a composition, is not a pure substance. Bronze is what? Bronze is an alloy. That means it's a mixture. Okay, mixture of two substances. One is copper, another one is tin. So how much percentage of tin is added in copper? 12%. You should remember this. Okay. So here you have bronze was one of the first alloys created by humans. So you have this one. This is what? Bronze. Okay, this is an alloy, and this is one of the first alloys that humans have created. So I hope you have understood this concept. Let's jump into the next. Okay students, so you have this concept of solution. Okay, solution constitutes of two types of substances as solute and solvent. This is very important for you. You need to understand this for this chapter, because you have some numericals regarding this concept, solute and solvent. So inside solution we know this is what? This is mixture of two or more than two substances. So inside solution you will find two parts. We can say inside solution you will find two parts. One is solute, another one is solvent. One is solute, another one is solvent. So what are solvent? Firstly we will understand about solvent. Solvent is the substances in which another substance is mixed is called the solvent. So in simple words we can say, whenever in a substance some other substances are mixed, so the first substance is called solvent. For example, if we take the example, then you will understand nicely. For example, water is a solvent in which we can mix different substances such as salt or sugar. So this is very easy example. You can say whenever you mix salt or sugar in water solution, then a solution is formed. Okay, whenever you mix salt or sugar in water, a solution is formed. Here the water is solvent because you are adding sugar or salt inside water. Okay, so the substance the substance where other substances are mixed is what? Is solvent basically. Then you have solute. The substance that is added to the solvent to form a solution is called a solute. So this is also pretty much easy definition. The thing which you are adding on other substance is what? Solute basically. So for example, salt when mixed in water acts as solute for the mixture. So in the sugar solution or in the salt solution, the salt and the sugars are solute and the solvents are the waters. Okay, I hope you have understood. Students, now we'll talk about properties of solution. First property is a solution is a homogeneous mixture. As we know, what is homogeneous mixture? When the particles are uniformly distributed. So all the solutions are homogeneous mixtures. Okay. Then the next one, we cannot see the particles of a solution through naked eyes as they are small as 1 nanometer in diameter. So this one also we know already. So solutions, the particles of solution are that much tiny that you cannot see them through naked eyes. Okay. The next one is the path of light is not visible through the solution. So the solution will not show you the path of light where the light is going. Okay. The particles of a solution do not scatter light for them as they are extremely small. So as you know that whenever the light is scattered from an object, then only you can see the object, isn't it? But these particles of the solutions are that much tiny that these are unable to you can say scatter the light, okay, or reflect the light. So that's why you cannot see them, okay, through naked eyes. The next one you have is we cannot separate the particles of a solution by methods of filtration. So filtration is a method where you use filter paper or basically filter paper or any kind of filtration mechanism, and by this way you can separate the particles basically. So in case of solutions you cannot separate the particles by filtration, and it's a physical we can say physical method or mechanism. Okay, so I hope you have understood. Now let's understand what is a stable solution. Students, you see, stable solution, a stable solution is a solution in which particles do not settle down. Particles do not settle down if you leave the solution undisturbed for some times. This is because the particles of a stable solution are homogeneously spread. For example, if you take a solution where you are adding some soil into water, okay, then if you stir it vigorously, then it will be a solution. Then after, if you keep it somewhere and if you don't disturb it, or if you leave the solution undisturbed for some times, then you will see the soil particles are settled at the bottom of the jar or the container where you are making the solution. That means they are not mixtured, like they are not making a homogeneous mixture. They are the particles are not we can say the particles are not mixed with each other. Okay, so in this case that will not be a stable solution. But if you take a solution where you are mixing some salt or some sugar into water, then you will see even after taking it, like after leaving the solution undisturbed for some times, then also you will see there is no residue, okay, in the bottom of the container. Okay, so that will be a stable solution where the particles are homogeneously spread. Okay, homogeneously spread, and you cannot see the particles also through naked eyes. So this is what stable solution is. Let's see what we have next. Students, the next very important topic of yours is different types of solutions. We have understood about solutions, what is solution and what are the properties of solution, we have already known. But the most important thing here is different types of solutions are there. First will be dilute solution. So let's understand it. A solution in which the concentration of the solute is much less than of the solvent. So we know about solute and solvent. Solute is the thing that is added. And solvent is the place or the thing where the solute is added, isn't it? So for example, if you mix 1 gram of salt in 500 ml of water, so you see 1 gram, it is very much less than 500 ml, isn't it? So we can say this amount of salt is very less, and this amount of salt is what? Is solute itself, and this 500 ml of water is solvent here. So if you are adding 1 gram of salt in 500 ml of water, the salt solution thus obtained will be diluted. If you keep on adding the solute in a solution, there comes a point when no more solute dissolves in the solution. This is called the saturation point of a solution. So this is also very much important, saturation point. and the solution will be called as saturated solution. So let's understand dilute solution first. So when you are adding like very less amount of solute in a large amount of solvent, then that solution will be dilute. Suppose you are adding, here the example is, here you are adding 1 gram of salt in 500 ml of water. So you see the amount of salt is very much less than the water. So here the solution that will be formed after mixing salt and water, then it will be called as dilute solution, where the amount of solvent is very much high. Okay, so now if you are continuously adding, means like in the 500 ml of water you are continuously adding salts, then what will happen, after some times there will be a point, or there will be a time come, then if you are adding more salt, then the salt will not be mixing with the water. Okay, will not be homogeneously mixed with the water. Then that point will be called as saturation point, where the amount of solute will not be mixed. Like after that, if you mix more solute, then the solute will not be dissolved in the water or the solvent. Okay, here in this case the solvent is water, so that point will be called as saturation point. Okay, I hope you have understood. So we can say saturated solution is a solution where the amount of solute is on its higher limit. Okay, that means the solute cannot be added more, so that solution will be called as saturated solution. I hope this is clear to you. So let's talk about unsaturated solution. A solution in which we can add more amount of solute as it has not achieved its saturation level yet is called unsaturated solution. So this is the opposite of saturated solution, as you can see here. So in case of unsaturated solution, you can add more and more solute in the solution, because the saturation point has not achieved yet. A dilute solution can be called as unsaturated solution. Okay, so this is, I think, clear to you, because here you have in the dilute solution the amount of solute is very much less than the amount of solvent. That means you can add more and more solute in the solution. Okay, next you have concentrated solution. A solution with a large amount of solvent is called concentrated solution. This is the opposite, we can say. Here the solvent is much more higher in this case. In case of dilute solution, the solvent is very much less, the solute is very much less, but in case of concentrated solution, here the solvent is in a large amount. The presence of solute is almost not there. Okay, the presence of solute is almost not there, so that will be called as concentrated solution. Then you have saturated solution. The definition is again given here. A solution in which no more solute can be added since it has already dissolved the maximum amount of solute, it can be called as saturated solution. Students, here you can see in the picture, this is a dilute copper sulfate solution, where the blue color is copper sulfate, the presence of or particles of copper sulfate. Okay, so here you can see the solution is clear. Okay, not that much bluish. So we can say here the amount of solute, that is the copper sulfate, is added less. Okay, if more amount of copper sulfate is added here, then it will be another kind of solution, which will be called as concentrated copper sulfate solution. Okay, that will be a strong solution. Then in case of saturated solution, you have to add more copper sulfate. Okay, more copper sulfate you are adding in the solution, then the number of particles, or we can say the particles of copper sulfate, will be more here in this solution. That will be called as saturated copper sulfate solution. So I hope you have understood this. Let's understand the next topic, what is concentration. So this is very much important for you. So students, here you see concentration refers to the amount of substance per defined space, or can be defined as the ratio of solute in a solution to either solvent or total solution. So if I tell you about concentration, we generally know that if I say about a field, okay, if I say about a field, and or we can say if I consider an area, and if there are some person standing on the place, okay, on the area, so this number of like 1 2 3 4 5, 6, 7, 8, 9, 10, 11. So here you can see 11 number of persons standing on a area. Okay, so I can say the population of this area would be 11. If I add more number of people, then the population would be more, isn't it? So earlier it was 11, now it is 11 plus, isn't it? So in comparison with the earlier case, in the first case, I can say the second case is having more concentration of people. Okay, so how I am saying this, because here you see in a solution, basically in a solution we know a solution is a mixture of solute and solvent, isn't it? So solvent is the place where you are adding solute. So if you are adding less amount of solute, then we can say the concentration of the solution is less. So the particles present inside the solution is less, so the concentration is less. If I say number of solute is more, means added more, then the concentration will be higher. So if I talk about concentration, then it can say it says that concentration refers to the amount of substance per defined space. So in a space, how many numbers of substances are present, or how much amount of substances are present, this refers to the concentration basically. Or we can say the ratio of solute in a solution. So this one, so I have already told you that in comparison with the solvent or the solution, the total solution, how much solute is present on the solution, that is being called as concentration. Okay, suppose like in case of a solution where the number of solute that you are adding is less, then that will be called as a less concentrated solution. And if the number of solute is added more, like in up to its saturation point, then it will be called as a higher or highly concentrated solution. So I hope you have understood. Then you have to calculate the concentration, consider the formula below. So we have some formulas, so these we will help during the numericals, okay, that we have in this chapter. So you have the first formula, this is percent by mass. So this will be called this will be found by mass of solute by mass of solution into 100. So we'll use these formulas while we'll do numerical of this chapter. Okay, so percent of mass equal to mass of solute divided by mass of solution. So the mass of solute we need to calculate, and the mass of solution would be we need to calculate, then we need to divide them, and you need to multiply this amount with 100, then we will find percentage of mass basically. And percentage of volume, this is the same case, volume of solute by volume of solution into 100. Then we have molarity, so it's a unit for measuring the concentration of solution. Okay, molarity. Then you have molality. So what is molarity here? Number of moles of solute divided by number of solution, volume of solution in liters. Then where mole of solute is given mass by molar mass. So I think these molarity and normality, these are new concept for you. So if you want, then I will make one video for this one, okay, by explaining molality and normality. So it's up to you. If you tell me, then I will make one. Okay, so you have this one, molality as small m, and it is found as moles of solute divided by weight of solvent in kilogram. Then you have normality, number of mole equivalent divided by volume of solution in liters, equal to, we can say, mass of solute divided by equivalent mass into volume of solution in liters. So these are the formulas. So these formulas will not use in this chapter, but these are considered as means for calculating the concentration. We have to use these molarity and normality. Okay, most important thing here is this percent of mass, percent of volume. Okay, so you need to remember this. Then you have parts per million is equal to mass of solute divided by mass of solvent into 10 to the power 6. Okay, then you have mole fraction of solute equal to moles of solute divided by total mass of solution. We will use this. Then you have mole fraction solvent, this is moles of solvent divided by total mass of solution. Then at last we have mole fraction of solute plus mole fraction of solvent equal to 1. So these are some formulas, okay, for calculating concentration. So you need to remember these. Most important is the first two, and some of the others are there. So this molarity and normality, these are new, I know. So if you want, then I will make one video explaining molarity, molality and normality. So it's up to you. You can tell me for making one. I hope these are clear to you. If you have any doubt regarding this, you know what you need to do. You can directly call me or you can WhatsApp me. I have noticed that very few students are clearing their doubts. I don't know whether you have understood or not, so let me know in the comment box here. So students, this is it for today. Thank you for watching. If you have any doubt, you know what you need to do. So I hope you are doing well at your home, you are studying well, and you are working on your weak points. Basically, you know, because weak points are the thing that deprive you from achieving your goal, isn't it? So do hard work at your home, because here in these lockdown days you are unable to go anywhere, you are not doing anything else. So one thing you can do, this is study and study. Okay, so I'm just signing off. Hope to meet you in the next video. God bless.